Hello again, this is Keith Davis at KLJ Instruments. In the previous videos I have discussed the operation of the synchronous, asynchronous, and WAM modes of operation. These modes provide a great deal of flexibility for programming various target scenarios. The remaining two modes, MOPS and ED-129, are designed for implementing specific tests. MOPS mode implements selected tests from RTCA DO-260B. These tests are intended to be used to verify airborne MOPS radios. On the other hand, ED-129 implements selected tests from EuroK ED-129. These tests are intended to be used to verify ground-based ADS-B receivers. In this video, I will first explain the operation of the MOPS mode, and then show the operation of the ED-129 mode. From the Squitter 2M main menu, I will select MOPS Testing, which takes us to the MOPS Test Selection menu. This menu has buttons labeled with the DO-260B paragraph numbers. Note that some buttons are grayed out, indicating these tests have not been implemented in the Squitter 2M. At the present time, only those tests which would be difficult to implement with conventional test equipment have been incorporated into the Squitter 2M. I will select test 2.4.4.3.4.7.3 Verification of criteria for data block acceptance in ADS-B message signals. You may enter the desired RF level, and the RF frequency is variable from -25 kHz to +25 kHz from the nominal 1090 MHz. Note that transmit quantity and transmit rate control the runtime for the scenario. MOPS address may be set to any value, and the format may be DF17, DF18, or DF19. I can select either 7 or 8 bits to be compromised, and I might enter 00, 01, 10, or 11 for the bit pattern. I will save this test with the name mDataBlock and compile. Exiting back to the MOPS Test Selection menu, I can browse the directory to find the test I just saved and run it. The oscilloscope shows that the data bits have been compromised according to the criteria of test 2.4.4.3.4.7.3. Now let's take a look at test 2.4.4.4.2.2 4-pulse preamble detection test. Across the top of the menu, we have the same parameters of MOPS address, RF level, frequency offset, transmit rate, and transmit quantity as in the previous test. Each preamble pulse may be set on or off. The width of each pulse may be varied from -0.4 microseconds to +5 microseconds from nominal. And the position of each pulse may be varied from nominal by plus or minus 0.3 microseconds. The relative amplitude of P2, P3, and P4 may be set equal to P1 or 2 dB below P1. I will leave all the pulse parameters as nominal, compile the scenario as M normal preamble, and run this test. The oscilloscope shows the 4 preamble pulses with their nominal shapes and amplitudes. Now I will modify the preamble. I will set the relative level of P2 to plus 2 dB, make P3 0.25 microseconds narrower than nominal, move P4 plus 0.3 microseconds, and increase its width by 0.35 microseconds, and save this test as M preamble. The oscilloscope reveals the distorted preamble. We will look at a sample of one more test, paragraph 2.4.4.4.2.3 preamble validation tests. Once again, we have the familiar parameters across the top of the menu. We can change the relative RF level, or turn selected bits on or off. I will select bits 3 and 4 to modify and compile this test as M data 3_4. In the oscilloscope, we can see that the relative RF level of the selected bits has been modified. The final discussion topic from the Squitter 2M main menu is the ED-129 mode. We can see that the ED-129 test selection menu is very similar to the MOPS test selection menu, but with fewer test selections. Each test menu presents the parameters that are required to run that test. Thank you for watching this series of videos that provide an introduction to the features and capabilities of the Squitter 2M.